Dear students, Assalamu alaikum. In this tutorial, we are going to learn how we can solve tabulation method with don't care conditions. Alright, so you can see that here is the given question. In this question, there are some main terms and there are some also don't care terms. Okay, so we're going to learn how we can solve such problems using tabulation method. So before going further into the details, I would suggest all of you to please check my previous tutorials to learn the basics about tabulation, because I'm not going to be explaining a lot of the stuffs in this tutorial, because I have already explained them in my previous tutorial. So please go through the previous tutorial so that you can understand this better. Alright, so let's move on. So our problem is divided into two parts, so I'm going to describe the first part here. So this is the main question given. Okay, so at first we're going to organize all of those terms in a sequential manner. So we're going to write down all of those main terms including the don't care terms sequentially in an ascending order. Alright, so here you can see 0 2 3 4 5 6 11 12 14 and 15. So all of those terms actually indicate the main terms and the don't care terms too. Alright, so we have written all of those sequentially in an ascending order, and we have also written the binary numbers for all of those numbers. Okay, so the binary numbers are written in 4 bits. That's because the highest number here is actually 15, so 15 can be represented using 4 bits. That's why you have written all of the numbers using 4 bits, and it can also be verified by looking at this face right there. The function is actually defined as ABCD, so all the bits are actually actually in the 4 bits in size. Alright, since there are 4 variables, so we have written all the binary bits, all the binary numbers using only 4 bits. Okay, so this is basically the step 1. So after step 1, we're going to divide all of those numbers into separate groups based upon number of ones in them. Alright, so here we can see that there is a term 0 which has absolutely no ones in them. So the binary code of 0 is basically 0 0 0 0 in 4 bits, so there is no one. So that's why this term here is included in a separate group. So this group is known as group A, and in group B, the group B will consist of defined binary numbers which have only single one in them. Okay, so group C will consist 2 ones, and group D will have 3 ones, and group E will have 4 ones. Alright, so this is how we're going to divide all those binary numbers into separate groups based upon number of ones, and we're going to put them into a different step, step 2. So we're going to divide all those numbers from step 1 and group them based upon number of ones, and then put them into step 2. So our step 2 will look something like this. So here you can see we have these 5 groups stated out in step 2, and there are different sets of binary numbers in each of the groups. Okay, so now let's move on to our next step. So this is how actually our problem looks like right now, step 1 and step 2. So we have just grouped all the binary numbers based upon number of ones in them. So what should we do next? So what we're going to do is that we're going to find single bit difference in step 2. Okay, we're going to find single bit difference from step 2 over there. Okay, so the mean terms of one group is basically compared to the mean terms of another group. So basically we're going to compare all the mean terms of group A with all the mean terms of group B, and then we're going to compare all the mean terms of group B with all the mean terms of group C, and so on. We are only going to compare one group with its immediate next group. Okay, so that means we're going to compare A with B, and we're going to compare B with C, and C with D, and D with E. We're definitely not going to compare A with C, D, or E. We're only going to compare A with B. Alright, that's because this phrase over here indicates that immediate next group. So that means we're only going to compare one group with its immediate next group. Alright, so that's why we're going to compare A with B, and B with C, and C with D, and D with E. Alright, so let's move on. So here you can see after the comparison we will be getting these numbers in step 3. So let me just explain a bit how we actually got these numbers. So here we can see that in group A we have 0, and in group B we have 2 and 4. Alright, so we're gonna compare the binary number of 0 with the binary numbers of with the binary numbers in group B. Alright, so we're gonna compare the binary number of 0 with the binary number of 2, and we're gonna compare the binary number of 0 with the binary number of 4. And as you see, if we compare 0 with 2, then there is only 1 bit difference in them. Alright, there's the third place, there's the third position, and at the third position we see 0 is written in case of 0 and 1 is written in case of 2. So this third position is actually indicating the bit difference, and all other bits are actually the same for both of these numbers. So that's why for this pair 0, 2, this pair the number is written like this: 0 0 dash 0. Okay, so 0 0 dash 0, that's how the number looks like. So same goes for the other pair too. If we compare 0 with 4, then we'll be getting 0 dash 0 0. That's because if we compare 0 with 4, we can see that the binary number for 0 is 0 0 0 0, and the binary number of 4 is 0 1 0 0. So at this second place it is 1, but at the second place of 0 it is 0. So there's the difference. So the place where we get the difference, we put a dash right there, and all the other places remain the same for both the numbers. Alright, so this is what we'll be getting from group A and B. Okay, and after that we'll compare all the minterms of group B with all the minterms of group C. That means we'll be comparing the binary numbers of 2 with binary numbers of 3 from group C, and we'll be comparing binary numbers of 2 with 5, 6 and 12, and we'll do the same for 4. We'll compare 4 with 3, we'll compare 4 with 5, and 4 with 6, and 4 with 12. Alright, so if we're done with the comparison from group B and C, then we'll be getting these values over here. So we'll be getting these pairs. So 2 3, 2 6, 4 5, and 4 6, and 4 12. So these are the pairs that we'll get for single bit differences by comparing group B and C. And then we'll continue our checking, we'll continue our comparison, and we'll compare group C with D, and here we'll be getting these pairs: 3 11, 6 14, 12 14. So only in these pairs we'll get single bit difference, and we'll write them over there. And similarly for group D and E, we'll also get differences, single bit differences, so we're gonna write them over there: 11 15 and 14 15. So these pair actually indicate single bit differences between group D and E, so that's why they're written here in step 3. Okay, so after finding out all the single bit differences, the total step will look like this one. The total step 3 will look like this one. Okay, so it's just written here. To know how we can find single bit difference, please follow the previous tutorial. I will strongly suggest you do so, even though I have actually explained here how we can actually do it, but to get a better understanding, I would suggest please go through the previous tutorial. I have explained everything by breaking down every single part in that tutorial. Okay, that's why I'm not explaining it part by part here. I'm just going through a bit first, but if you want to know how they work part by part, please go through my previous tutorial. All right, so let's move on. So this is our basically step 3. All right, so what we did here is that after grouping them in step 2, then we actually compared the minterms of one group with the minterms of another group. Basically the minterms of one group are compared with the minterms of immediate next group. So A is compared with B, and B is compared with C, C is compared with D, and D is compared with E. And we actually compared for single bit differences, and whenever we get the difference, we put a dash at that specific place, and the other bits remain same. And this is how the step 3 looks like after all those comparison. Okay, so there's our step 1, step 2, and step 3. Now since we're done with finding out the single bit differences in step 3, now we're gonna put some tick marks beside some of the numbers of step 2. So whenever we are done with finding out single bit differences, then we're going to go back to the previous step and we're going to put some tick marks. So here we're going to put some tick marks beside some of the numbers of step 2. So let's see how we can do that. So we're gonna check from step 3 and we're gonna put ticks into step 2. So for the very first number over here, let's check. Okay, let's put tick marks. So for the very first number over here, 0 2, the pair, as you can see, the 0 2 pair is actually consisting of 0 and 2. So we're going to go back to step 2 and we're going to put tick marks beside 0 and 2. Okay, and for the next one, the pair of 0 4, it consists of two numbers, 0 and 4. So we're going to go back to step 2 and we're gonna put tick marks beside 0 and 4. So we only put tick in the place of 4 because, as you see, the 0 was already checked before, so we don't need to put another tick mark over there. So we'll follow the same procedure for all of those pairs. So for 2 and 3, we're going to put tick marks on 2 and 3, and for 2 and 6 we're going to put ticks on 2 and 6, and we're going to follow the same thing for all other numbers. So let me just go through the simulation so that I can finish it up. So this is actually really easy. We're just gonna check the pair and we're gonna go back to the previous step and we're gonna put tick marks beside those numbers which we have actually considered in the pairs in case of step 3. Okay, for example, we have 6 and 14 here, so we'll put tick marks beside 6 and 14. 6 was already checked, so we just put tick mark on the 14. All right, so 12 and 14, so both of them are already checked. 11 and 15, 11 is already checked, so I'll put tick marks beside 15, and 14 and 15, so these are already checked. Alright, so we are done checking all the pairs of step 3, and we have put tick marks on all the necessary places in step 2. So this is the scenario after putting all the tick marks. We're done with step 3 now. Now let's move on to step 4. So what we're going to do in step 4 is that we're going to find some double bit differences. Okay, so what do we mean by double bit differences? So what we actually mean is that we need to compare now. So what we need to compare is we're going to compare all the main terms of step 3. We're going to compare all the main terms of group A in step 3 with all the main terms of group B. Alright, so basically we're gonna compare them as pairs. So the 0 2 pair will be compared with 2 3, and then it will be compared with 2 6, and then 4 5, 4 6, and 4 12, and the similar thing will be done for the 0 4 pair too. Alright, so we're gonna compare the binary numbers, and what we're actually looking for is the double bit difference. So the double bit difference means is that one dash position match and another bit difference. That means the dash is already indicating a single bit difference. All right, all of these binary numbers have dash among them, right? So the dash is already indicating a single bit difference, so we're gonna match that specific position, and if and only if the dash position matches, only then we have to look for single bit difference except the dash. That means we're gonna look for another bit difference except the dash. All right, so let me just show you an example so that it is clear. So let's say we're gonna compare 0 2 of the first group with a pair of let's say 4 6 in group B. Alright, so if we compare 0 2 with 4 6, then you can see the dash position is actually matching right there. So for 0 2, the dash is at the third place if we count from left, so the dash position is at the third place, and for 4 6 the dash position is also at the third place. So the dash position definitely matches. Since the dash position matches, so that's why we're gonna consider the second condition now, and the second condition says that if the dash position matches, then we need to find a single bit difference. And as you see, the 0 2 pair is written in binary as 0 0 dash 0, and the 4 6 pair is written as 0 1 dash 0. So here at the second place from the left side, we can see that we can get the difference. For 4 6 it is 1, and for 0 2 pair it is 0. Alright, so here we can see that there is only one bit difference and the dash position also matches, right? So that's why since both of these conditions actually are matching with our what can I say, our necessity, so that's why we are gonna put 0 2 and 4 6 into step 4. Okay, we're gonna write them together, 0 2 4 6, because we got the match using these two pairs, 0 2 and 4 6. We're gonna write them together, and we're gonna write the binary number here too. So how can we write the binary number? The previous dash will remain as it is. All right, the previous dash will definitely remain as it is. The previous dash was at the third place, so it remained as it is, and here we are getting a new difference at the second place right there, so that's why we're putting a new dash here. Okay, so the previous dash will stay as it is, and we'll put a new dash at the new difference we're getting at this step, and on the other bits will remain unchanged, right? So 0 2 4 6 will produce a result of 0 dash dash 0. All right, so let's move on to our next step. So the same thing can be done for this pair too. 0 4, if 0 4 is matched with for what can I say, 2 6. Okay, in that case we can also see that the dash position actually matches the second place, the dash position matches, and we can get a single bit difference at the third place. All right, so since both of the condition matches, so so that's why we put 0 4 and 2 6, both of these pairs, into step 4. So 0 4 2 6 written together, and the corresponding binary is 0 dash dash 0. Okay, so basically from group A and B we can only get these numbers. All right, so we can only match 0 2 with 4 6, and we can only match 0 4 with 2 6. No other match was found, that's why only these numbers written in step 4 from group A and B. All right, and similarly for group B and C we can write these pairs. All right, 4 6 can be matched with 12 14 to get our necessary condition, to match our necessary condition, and 4 12 can be matched with 6 14, which actually matches both our conditions. All right, so that's why these are written together in step 4. So basically step 4 will look something like this. So okay, if I show you this easier way, then I'll say that from group A and B we're getting these numbers, and from group B and C we are getting these numbers. Okay, and here you can see that from group C and D I did not write anything. Well, that's because from group C and D we actually don't get anything that actually matches our conditions. All right, so that's why from group C and D we could not produce any more pairs, so that we did not write anything in step 4. Okay, so let's move on to our next step. So now that we're done with step 4, we're going to go back to our previous step and put tick mark beside some of the numbers. So basically we're done with step 4 now, so we're going to go back to step 3 and we're going to put some tick marks beside some of the numbers of step 3. So how can I put tick marks? Okay, so I'm gonna put some tick marks by following a simple rule. So the rule is right here. We'll put tick mark beside those pairs in step 3 which we have taken into step 4. All right, so let's see the first one. So for the first one, 0 2 4 6, you can see that the pairs taken here are actually 0 2 and 4 6. So we are going back to step 3. Let me just rewind. So 0 2 4 6, we are going back to step 3, and we're putting tick marks beside 0 2 pair and 4 6 pair. So let's see another one. For 0 4 2 6, we're going back to step 3 again, and we're putting tick marks on 0 4 and 2 6. So we're gonna do the same thing for all of these numbers, 4 6 12 14. So we're gonna go back to step 3 and we're gonna put tick marks on 12 14 and 4 6, all of these pairs. All right, so these are the pairs that were actually taken into step 4, right? So that's why we're coming back to step 3 and we're putting tick marks beside those pairs. All right, so for 4 12 6 14, so yeah, 4 12 pair right over there, putting tick mark beside that, and 6 14 pair, we're putting tick mark beside that too. Okay, so all of our checking is done. So all the number we have traversed through all of those numbers in step 4, and we have put tick marks on all the necessary places in step 3. So that's basically our step 4, and step 4 is completely done now. So this is how our math looks like. right now. So let me ask you a question. So can you do a step 5 from this step 4? Okay, so basically there are two different groups, so definitely we can try to calculate step 5 from here. If we can compare the min terms, the binary numbers written in group A with the binary numbers of the min terms of group B, then if we can somehow match the necessary conditions, then we might get a step 5. All right, so let's see if we can find anything. So basically, to do a step 5, we have to match both dash positions for a component from group A to a component from a group group B. So that means from group A, if we take these numbers to this group right there, 0 to 46, so if we consider the binary number for this group 0-0, we're going to compare this binary number with the binary number for this group 4, 6, 12, 14 in group B. So what we're trying to match here is that at first we're going to match the dash positions. All right, so since there are two dashes in all of those binary numbers, so that's why at first we're going to match both of those dashes positions. All right, so since so when we get that matched out, that means both of the dash actually match together. After that, we're going to find another single bit difference. So basically we're looking for 3-bit differences right now, so 2 dashes and another single bit difference. So if we look carefully, we will see that there is absolutely no such difference found in case of group A and group B. So when we compare all the main terms, all the groups of group when we compare all the binary numbers of group A with the binary numbers of group B, we can't find any such matches. All right, so that's why we can't do a step 5 in this problem. All right, so the answer of this question, can we do a step 5, will be here. We don't see any such scenario, we don't see any such matches, we don't see any such scenario which actually satisfies these conditions. That's why we can't do step 5 for this problem. Okay, so basically our problem looks like this after completing step 4, and let's move on to our next task, which is actually finding prime implicants. So for our next task, we're going to consider those terms in our problem which don't have tick mark beside them, and we're only going to consider that for step 2, 3 and 4. We're not going to consider that for step 1, because in step 1 we just rearranged our given min terms in a sequential order. All right, so nothing else, no group was considered here, so that's why we're going to ignore step 1 and we're going to take into consideration step 2, 3 and 4, and we're going to find those terms which don't have tick marks beside them. So let's see. So here are the terms which don't have any tick marks beside them. You can actually check it for yourself. So 2, 3, 4, 5, 3, 11 and so on. So we have written all of those main terms here, and we have also represented them using variables. So the question given here indicated the function as a, b, c, d. The function was defined with a, b, c, d. That's why we have used a, b, c, d here for our convenience, and we have represented all of those binary numbers using our variables a, b, c, d. So the rule here is that we actually ignored the dash completely. We actually ignored the variable respective to the dash, and we just wrote the binary, we just wrote the representation for all other binary numbers. So for example, for the first one, the pair of 2, 3, we can see the number is 0, 0, 1 dash. So since the dash indicates the position D, so we're going to ignore D completely, and we're going to write the representation for the rest of the numbers. So 0, 0, 1 indicates A prime, B prime and C. That's why you have written here A prime, B prime, C. And for the next pair 4, 5, the same thing, the dash is at the 4th place, so we're going to ignore D completely, and we're going to write the representation based upon the rest of the numbers. So 0, 1, 0, so basically A prime, B, C prime. Alright, A prime, B, C prime. So I have followed this procedure and written the representation using variables for all of these binary numbers, and these are our prime implicants.